Well, thank you, and welcome for this talk here at Connected Media IP. So, with a rather long title today, this is Can OTT be a substitute for traditional broadcast TV? How to preserve broadcast quality and user experience from the encoder-packager perspective. So that is a long title. I will explain in a bit more detail why we address that specific question. So what are we talking about, and really who cares? Traditional broadcasters do, and as a matter of fact, we all know that OTT TV technologies are now mainstream, and traditional TV broadcasters have added these technologies to their delivery chain. That was an addition to reach new audiences. So right now, broadcasters use two delivery paths. One is a broadcast path, and they added the OTT path. So now they may wonder if they can replace the broadcast path with the OTT path. So can we get rid of this and just use the internet or OTT delivery? So can they? This is exactly the topic of that talk. Can broadcasters rely on using OTT TV technologies alone to deliver their services, keeping the same user experience and video quality? So this is a technical talk, and I will talk from the encoder and packager perspective. All right, so the question is this. As a broadcaster, can I use OTT technologies as a replacement for broadcast? Will I keep my video quality? What about latency, zap time, even interlaced content? Can I support it with OTT delivery? Second point, will I keep all my services and metadata? So you can see a list here, which is even a partial list: ad insertion, EPG, parental rating, emergency alert service, hearing impaired loudness. Will I keep this with OTT TV? How do I keep that? So some services are for added value only, such as ad insertion. Some are mandatory per regulatory compliance. So you absolutely need to preserve those services when switching to OTT TV. And the third question will be about the delivery chain. What about continuity of service? I've heard that internet delivery is not reliable enough for broadcast, so is it safe to use it? So we'll try to answer those different questions in this talk. And what are the reasons to be concerned, really? Well, as you know, OTT has different technical ground than broadcast TV. The first one is that in traditional broadcast TV, you rely on a fixed transmission link that is controlled. So that is, you have a serial link. You have control on, and this is true even for IPTV. So when I say broadcast here, I include satellite, DTT, cable, and also IPTV. In OTT TV, you have to work on a totally or partially unmanaged network with no control. So that's point one. Point two, in broadcast TV, it works in push mode. That is, the broadcaster always sends the data, whether the receiver listens to the data or not. So the receiver, the set-top box, the video player is passive and just has to wait for the data to flow in. In OTT TV, this is the exact opposite. The player is active and downloads actively the data from the network. So we'll see that has some technical consequences. And the third point is another version of the third one, or the first one. Actually, this is with a broadcast TV, the transmission is guaranteed, even if this is one way. You can use, for instance, forward error correction codes for that. Whereas in OTT TV, you work on unmanaged networks, so transmission is not guaranteed. But the player has access to many variants. So this being said, let's start with video quality. So broadcasters may have heard that OTT is for the low video quality market. OTT implies long zap times and dramatic latency. or even OTT cannot do interlaced video. but they have a reputation to maintain. So what is true and what can be done? About zap time and latency. So this is really one of the most important points for broadcasters. This diagram will explain the differences between broadcast protocols and OTT TV protocols for zap time and latency. So in broadcast, the data flows in the decoder as time goes on, whereas in OTT TV, it's made available all at a time. So in broadcast, as time grows, you receive data, sometimes with IDR pictures, iframes, iPictures. With OTT TV, if you consider it from now, when you start your player, you have immediate access also to past content. So that is a major difference. The player is passive, the player is active. So how does it affect on zap time? So if you zap in a broadcast scenario on a set-top box, when you start, the player is not necessarily able to start decoding data. It has to wait for the first bit that it can decode, and that is an iframe. So it has to wait until an iframe starts, then it starts buffering data. It stops discarding, starts buffering. And then after some buffering time, it will start playing. So that buffering time is what we call CPB delay. This is for HRD compliances. This is a mandatory delay that set-top boxes have to respect so that they are sure they will play the stream continuously. So if you consider it now from now, the zap time in broadcast is T2 minus T1. This is zap time. All right? This is for broadcast. In OTT, the situation is different. In OTT, past content is available. So when you zap now, actually the player may decide to immediately download data from the past. So it can start downloading a past chunk and start with an iframe directly. That means that actually in OTT TV, you could have a shorter zap time than in broadcast. About latency now, what we've seen in broadcast is that the player has to start after a given delay, a normative delay. That delay is the latency. Okay? So the latency here depends on the what we call the CPB delay in broadcast scenario. In OTT scenario, we've seen that the player may decide to download a past chunk that might be very far in the past. In our case, in our example, 30 seconds. So the latency here will be 30 seconds. So here you have a short zap time, potentially, but a huge latency. Also, some latency can also be added by the video processing algorithms themselves. For instance, I don't know, the interlacing, video compression, look ahead can add latency to the entire processing chain. So that's also a parameter to consider. So what can be done? How can we reach the same zap time in OTT TV as in broadcast TV? So I won't read the full detail, but this is the reasons why we have a high or low zap time and what we can do about it. In OTT TV, what we can do is we can act on chunk size in bytes, that is the GOP size, to reduce zap time. This is unsure it has an effect because it also depends on the player's own behavior. So it depends how the player is implemented. But it can be low anyway. You've seen that the player can access to past chunks, so there is a way that the zap time is quite short, even for OTT TV. About latency, picture is a bit different. So as we've seen, you can work on the encoding or processing algorithms to reduce the intrinsic latency in the video compression stage itself, working on pre-processing, the interlacing, and so on. Again, it will depend on how the player is implemented. And actually, you have other possibilities to reduce latency. You can, with specifically designed players, you can use smaller chunks, that is what we call sub-fragments in OTT TV, or even partial chunks. That is, the player will start to download a chunk and start playing back even before the download is entirely complete. So that is a way to reduce latency. But it requires a specific player or even tricks in the delivery network. So that was for zap time and latency. We're still on video quality now, talking about the video compression stage itself. So that diagram shows the different rate control algorithms that can be used in TV, in live TV. In traditional broadcast TV, we can use, you're familiar with the regular CBR rate control, constant bit rate, that has to be used for serial transmission over a link that has a fixed bit rate, bandwidth. For a better video quality, you can use VBR, variable bit rates. Okay, so you reduce the encoding constraints. You can now have a variable bit rate. That allows your encoder to grow the video quality. You can increase the video quality. There is another version called capped VBR, which is the same as VBR, except you can reduce the bitrate if the target video quality is reached. So it doesn't increase the video quality, but it helps you reduce the necessary bandwidth for transmission. That is for broadcast TV. For OTT TV, actually you have less constraints again. So that means you can reach a better video quality than broadcast. For instance, in CBR, we said we had to comply to HRD. In OTT TV, we don't. So we can encode with a new rate control mode that is called ABR, that is suitable for chunk-based delivery, and that has less constraints than broadcast TV, and so can provide a better video quality. Some vendors have a different version of that they call capped ABR, CABR, or different technologies, which is the same as ABR, but where you can save bits if a given quality is reached. So that diagram is here to prove that you can actually reach a better video quality in OTT TV than in broadcast TV, which looks unnatural at first sight. One word about this capped ABR thing. So actually in standard ABR rate control, you deliver a list of profiles. And for instance, you will deliver 2 meg on the other profiles, and you have a limited chunk size variability. This is as per the HLS standard, for instance. You're not allowed to have big variation. If you release that constraint, you can have a better video quality. So that's why we can call capped ABR. That means for those chunks, if the content is transiently easier to encode and you don't need that many bits, you can reduce the chunk size. So that means you allow for more variability. You can reduce the number of bits for some profiles. And for some profiles, maybe you can't because you're already at the lowest level of video quality. So that means with capped ABR, you have less bits than ABR, and ABR, you have a better video quality than broadcast. Okay? One last point we can address about video quality is about how to handle interlaced content. So, well, in a few words, if you have interlaced inputs, there are many different ways to deliver that to OTT TV. Some are compatible with set-top boxes, with smartphones, with TV sets, and some are compatible only with interlaced displays and also with progressive displays. So actually, this diagram is here to say that there is always a way to handle interlaced content, whether you want to convert it to progressive or whether you want to keep it interlaced for your OTT delivery. Okay, summary on video quality. So the video quality can be preserved or even improved as compared to broadcast, we've seen. Then what about services and metadata? So this is the list we've already seen. What can we do about them? some are mandatory, and they need to be covered when we switch to OTT TV. Broadcasters don't have a choice. So hopefully some standards exist. Well, there is the famous HLS Pentos RFC, which, among other things, explains how to perform ad signaling, multilingual, and captioning in some formats for OTT delivery. There is ACT 214-1, which explains ACT 35 color signaling, for instance, or closed caption 608, 708. They explain how to convert that from broadcast formats to OTT TV formats in MPEG- specifically. In the DVB world, there is the HCTS 103-85 that explains how to convert to convey content program metadata, that is EPG and parental rating, for instance. There is a way, normative way, to convey that in MPEG- for OTT TV. So I'll go for one example about parental rating that is called content advisory in ATSC world. This is mandatory to cover that. So how do you do when you switch to OTT TV? Well, you have to use the ATSC description of parental rating. So you have a table in the transport stream, or in DVB you have another table, another syntax, and then there is a way to convert that to MPEG-. So there is a norm that explains that you have to send in each dash chunk a message that contains the parental rating. So for instance, the age will be here, and you have your OTT delivery chain has to convert from the age that was put in that table. So that means there are ways to deliver all that information even to OTT TV player. So this is not common. This is not something that everyone has today, but this is becoming mandatory. So this is something broadcasters have to take care of. Also, there are some tricks that can be added so that the player doesn't have to wait for the data to be received, but can actually ask for it, ask for content advisory changes on request, so that it has a frame accurate information. Maybe the last question that broadcasters may want to address is about continuity of service. So they wonder how robust is OTT TV delivery as compared to their traditional broadcast delivery chain. So OTT, is based on the internet. Internet is designed to be resilient when we talk about connectivity. All right. So this is mostly a question for the carrier or the CDN vendor. And from the bandwidth point of view, the OTT protocols are designed to survive bandwidth fluctuation of the internet. What can we do about resiliency? So from the encoder packager point of view, which is really my focus today, you can build a delivery chain which is 1+1, active-active. Your encoder packagers will receive the same HDI streams, the same live content, and will publish each of them to two different publishing points in the CDN or over the internet. And then the player has to be able to pull from either source. The tricky part here is that the broadcaster has to be sure that the encoder and packager he selected are able to publish chunks, OTT chunks, in such a way that the player is able to switch seamlessly. So that means that chunk naming, timing, cross-referencing in the playlist manifest files have to be carefully taken care of because that is how the player will be able to switch without any interruption. So if one encoder goes down, there will be continuity of service and with no interruption, actually, with no glitch. Okay? So again, this is not a feature that is common. That means the encoder packagers have to be specifically designed for that purpose with careful synchronization between the two instances. Let's go back to the initial questions and the conclusion. So, as a broadcaster, can I use OTT technology as a replacement for broadcast for my traditional network? So, about video quality, we've talked about zap time, interlaced compression efficiency. They can be easily covered. Latency is the tricky part, but some solutions exist. So actually you can reduce the chunk size. You can act on the CDN itself with clever delivery to forward chunks in advance, for instance, or even player tricks. That is, the player has an active role in reducing latency. So that can be covered as well. About services and metadata, that can also be covered because all those services are detailed in different standards. So if your encoder packager implements those standards, it has to, then that means you will keep your existing services. About the continuity of service, I think we have covered that point as well. You've seen that with a specific design, seamless redundancy can be available. So, can I use OTT? My answer would be yes. The OTT technologies are mature enough to replace the broadcast path and be used as the main delivery path even for broadcasters. To finish, just a word about ourselves. So we are called Keepixo. We build video encoders and packagers for OTT TV since 12 years, about so. And we design, so this is, our work is to convert existing TV feeds, like broadcast feeds, to OTT TV formats, and we supply the blue functions in that processing chain. So today, I've been mainly dealing with those two boxes, the OTT packaging and the live encoding part for video compression, the capped ABR discussion. So this is what we do at Keepixo. So we supply OTT encoders that can be used by broadcasters, ISPs, telcos to convert live TV to OTT TV. So I won't go into further details. If you have any questions, please, we'd be happy to see you on our stand at here at NAB. Thank you.